Preview.
Welcome to Valdymas College. This video is the continuation of the rules guiding the naming of branching alkane. So in this video, I'm going to explain rule number 7. Rule number 7 states that in case two chains of equal numbers of carbon atoms compete for selection as the longest chain, that is the main chain, so select the one that has the greater number of substituents attached to it. So to take our longest chain, to determine our longest chain, we have to select the chain that is with highest number of substituents. So the main chain is the one with the highest number of substituents. Okay, so let's take this example. So this structure, so what we have there, CH3, CH2, CH. Don't forget, you have to obey the tetravalency of carbon and the monovalency of carbon. So now let's start the numbering of the carbon atom to know our longest continuous carbon chain. Okay, so let's start the first one from this side. So we have 1, carbon 2, carbon 3, carbon 4, 5, 6, 7. So starting our counting from this end, we have 1, 2, 3 to 7. Then how many substituents do we have on this main chain? We have 1, then 2, we have this to be 3, right? So for this first one, number 1 is with how many substituents? 3 substituents. Now let's take another route and see if we can have more than 3 substituents on it. So that will be our number 2 chain. So for the second one, we are going to move in this direction. 1, 2, 3, 4, 5, 6, 7. Don't forget, like I said earlier, your chain can continue like in this format, so don't be confused with the structure. So now for this main chain in this direction, how many substituents do we have on it? Let's take a look. Then we have on carbon number 2, we have the first substituent. On carbon number 3, we have the second substituent. Carbon 5 is having this substituent here to be the third substituent. Then on carbon number 6, we can see this compound here. Compound here is for carbon number 6, so we have this to be the fourth substituent. So for the second chain that we are looking at, we have 4 substituents. So based on the rule states that while numbering, we have to take the main chain to be the one with the highest number of substituents. So we are going to take the one with 4 substituents as our main chain. So then now we are going to follow other rules so as to assign the correct naming. for the compound. So now let's name it. So on carbon number, so now on carbon number 2, we have methyl. So carbon 2, C2 is having methyl, that is 2 methyl. Then on carbon number 3, we are having carbon number 3 is ethyl, so that is 3 ethyl. Then on carbon number 5, at this point we are having another ethyl here. So we are having on carbon number 5, we are having 5 ethyl. Okay, then on carbon number 6, we are having 6 methyl. So carbon number 6 is we are having 6 methyl. So if you are going to use this way to name it, the name is going to be in this direction. So so to arrange everything together, don't forget you have to obey the alphabetical order. So now the longest continuous chain, the maximum number of carbon in it is 7, so that is heptane. So you have to write the parent name as heptane, then you have to rearrange this in alphabetical order. So E should come before N. Now we have 2 ethyl, right? And based on rule 5 and 6, you have to put di or tri once they have occur twice or 3 times. So ethyl occur twice and methyl occur twice, so that should be 3, 5 di ethyl. Okay, don't be confused with the di, that is the arrangement of alphabet, but what you have to look at is the ethyl and the methyl. So 3, 5 di ethyl, then we have the methyl coming in, then our methyl is 2 and 6, so that is 2, 6. So since it's 2, it is also di 2, di methyl heptane. So the name is 3, 5 di ethyl 2, 6 di methyl heptane. Okay, so that is the correct naming for this compound. So next, now I'm going to explain rule number 8. Rule number 8. What is rule number 8 talking about? Rule number 8 is talking about when we have a complicated structure. So now it states that a complicated branched chain is named as a derivative of the longest chain or the main chain in that compound. This chain is numbered starting from the carbon atom attached to the main chain. Okay, its name is constructed on the basis of the IUPAC rules, that is all the rules we've been talking about, and is enclosed within parentheses to distinguish it from the main chain. So for us to understand this rule better, let's take this structure again as our example. Okay, so when we have something like this, CH2, compound, we're going to have a complicated structure here. Okay, so we have another one here. So as you can see, this structure is complicated with numbers of substituents. Then okay, from this structure now, the first thing we have to do is to assign the numbers to the carbon atom so as to know our longest chain, the main chain. Okay, so let's start from this side to know the substituent. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. So now, starting our numbering from this side, we have 8. If you have to go back again, we are going to have 8. If you are going to start from here to, we are going to have 8. So can we take another route to know if we have other options? So let's start our numbering from this side. So if our numbering should start from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. As you can see, we have 9 versus 8. So we are going to select the 9. We are going to make the 9 our longest chain, that is the main chain. So 9 is our longest continuous chain. So 9 is obtained. Then the next thing is to get our substituent. So it means that our chain is in this way. If we start from this end 1, or this end 2, or this end 2, we are going to have 9, and we are going to arrive at this junction as our substituent. Okay, either you start from this way, numbering 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to have the same thing either way. So we have to take this as our main chain. So we have octane. So we have to write the name, or sorry, since we are taking 9, our main chain is nonene. Nonene, that is 9 carbon atom rather than 8 carbon, which is octane. Then our substituent now is conferred to this region. So how are we going to name this side? Are we going to call it 1, 2, 3 propyl 2-methyl? So this rule helps to assign name to this bulky substituent. So the rule states that we have to start another naming if we have complicated substituent like this. So we have to start another naming from this side. So let's start the numbering again. So what you're going to do, once you detect a complicated substituent, you have to start another numbering on the substituent. So the numbering is going to start on the first carbon. So you are going to take this as carbon 0. So you're going to start from here, 1, 2, 3. Okay, so here we have 1, 2, 3. So we are having one. The name of this substituent now is going to be 1. On the carbon 2 we have 2-methyl. So we have we call it propyl. Since it's still a substituent, we can't name it as dimension. We can't call it propane. It's still propyl. 1, 2, 3 propyl. Then the propyl is having 1, 2, 3 substituents. So we have 1, comma, then we have 2, 2, comma 2. Since there are 3, that will be tri methyl propyl. Okay, do we get that? So let's take it again. You have to start your numbering from this carbon that is nearest to the carbon that is carrying the O branch. So so starting from this carbon now, we have 1, 2, 3. Then assign the name to the 3, since it's a substituent, to the main chain, that you call it propyl. So you are going to call it propyl because it's a substituent to the main chain. Then the propyl is having other substituent on it, that is on the carbon number 1 and the 2. On carbon number 2 we have 2-methylamide. So we are going to name it as 1, 2, 2, since there are 3, 3 methyl. So we are going to name it as tri-methyl propyl. Okay, now we are going to join this together to the name of the main chain. This is our main chain. So we are going to join the name together. So to add this together now, we have to indicate the position of this whole substituent, this complicated substituent, the position on the main chain. The position on the main chain is 5, right? So it started from the carbon number 5. So you have to state it that is from 5. So you have to put 5, then you add it to the main chain. So that is 5 into open bracket, then you open a bracket for it. That is indicating that on position number 5 we are having this complicated structure, that 1, 2, 2 tri-methyl propyl nonene. So that is the name. So the name altogether now is 5, 1, 2, 3, then tri-methyl propyl nonene. So don't forget, whenever you have a complicated substituent, you have to start another numbering, then you add everything together to get the correct name. Okay, thanks for listening.